Hey, what's going on, guys? Let's do this problem right here. The question is asking, question is saying the basic barometer can be used as an altitude measuring device in airplanes. The ground control reports the barometric reading of 753 millimeter mercury, while the pilot's reading is 690 millimeter mercury. Estimate the altitude of the plane from the ground level if the average air density is equal to 1.20 kilogram per meter cube. So let's see how we can calculate. So here what we can do, first of all, let's calculate this pressure, atmospheric pressure in this height. Uh, like this is from plane, reading from plane, right? So reading from plane, P plane is equal to this reading 690. So we also can equate this one to find, like we can equate this one to rho gh, right? Rho gh, and here the h is gonna be this one, millimeter mercury. That's the height, representing the height of the mercury level, right? So let's see how we can calculate. So rho is gonna be density of the mercury, that is 13,600 yeah, 13,600 kilogram per meter cube. That's the density of the kilogram per meter cube, times G is 9.81 meter per second square, times this one is 690 millimeter mercury. This is in millimeter, so we have to convert this one into meter. That's going to be 0.690 meter mercury. And if you calculate this one, this value gives you 92.06 kilopascal. So this is the atmospheric pressure measured from the plane. So let's see what they measured from the ground level. So in the ground level they have measured P ground. So P ground, we have rho gh again, that is 753 millimeter mercury. This is the height difference of mercury, and let's calculate in terms of these things. So we have density of the mercury, that is 13,600 kilogram per meter cube, multiplied by 9.81 meter per second square, times 0.753 meter mercury, right? So if we calculate this one, we get 100.46 kilopascal. So this is showing two different, like from the ground this atmospheric pressure reading is this, from the plane atmospheric pressure reading is this. So how we can use this one to find the altitude of the plane from the ground level? So that is the question, altitude of the plane from the ground level. So that's what they are asking. So let's see how we can do this. So here we can, if we can find the height of the air, right? P air. If I use P air, that's going to be difference of these two. If I subtract P ground minus P plane, that's going to give us pressure of the air. The pressure of the air changes as the height increases. As the height increases, basically the density of the density decreases and pressure also decreases. As the height increases, pressure decreases. So that's the relationship between the pressure and the height. So that's why the pressure is changing, right? So if I find the pressure due to air, pressure of the air, I can from this one I can find the height, because rho g, pressure of the air also going to be rho gh. We know the density of the air is provided, that is 1.20 kilogram per meter cube. Rho g is 9.81, and this height difference, this height is going to give us the height is changing the pressure, right? So this height is going to be the altitude of the plane. So let's calculate this one. So P ground we already calculated already, that's 100.46 minus this P plane, that is 92.06, and if we subtract, let's see what we get. So kilopascal, if you subtract this one, we get 8.4 times 10 to the power of 3 Pascal, and all we have to do is we just rearrange this one to find the h. So let's continue that one right here. So therefore h is going to be equal to 8.4 times 10 to the power of 3, and if we multiply this one together, this will give us 11.772 times h, and let's divide this one by this 11.772, and if you divide, you will get the height that gives us 714 meter. Therefore we can conclude that the altitude of the plane from the ground is altitude of the plane from the ground level is 740 meter, and that's how we find these answers. I hope you guys liked this video. See you next time.